So in this these three different types of expression, for our naked whenever you are writing program in any language, you are giving expressions like this: 2 plus 3 into 4 minus 7. You are giving some lengthy expression like this. But compiler in mathematics subject, we will try to do, we have to follow the operator precedence. So you will identify that multiplication is having more priority, that you will do it first, then left to right logic you will apply. But internally, compiler is not evaluating in that approach. What compiler is doing? Compiler is converting this given infix expression into postfix, or prefix. For now, assume it is converting into both. It is either converting into postfix or prefix and then evaluating it. Why? Because the time taken to evaluate an infix expression, okay, and the challenges what we have with the infix expression, those challenges we don't have that in prefix or postfix expressions. Here it is very easy to evaluate. One main difference, if you see here itself in this example, if you see, I have an expression a plus b in bracket plus c minus d in bracket, right? So this is my infix expression, and if you remember the operator precedence table, I'll just show you. Yes, so this is the operator precedence table, right? So you see, round brackets has more priority. It means we have to do that first, then only comes your all the other operators. So if I go here, I have to complete the brackets part first. Even though I have an expression like this, a plus b in bracket plus, here I have c minus d, multiplicate, or maybe let me put one plus some 3 into 4 is there, right? When you have an expression like this, are we evaluating multiplication first? No, we are doing brackets first. So it's an overhead for the compiler to maintain the open bracket, again check whenever the close bracket has encountered, take this expression, evaluate it independently and give the solution. It's always an overhead or a headache kind of a thing whenever I have this open and close brackets. But if the same expression, if I convert that to either prefix or postfix, we don't have the brackets. Brackets are removed. Brackets are removed, right? That is one advantage we have here with the infix or prefix or postfix notation. See the example, a plus b plus c minus d. It became an expression like this without any brackets, or otherwise you have to use some extra spaces. You have to use some extra spaces to hold this open bracket, then close bracket, like we have done in the example of balancing the symbols, right? That balancing of symbol logic, additionally you have to write it. It's an overhead for the compiler. That's why we are studying the other two notations, that is prefix and postfix. So in whatever programming language, if you are giving a expression 2 plus 3 into 4, for your naked eyes, you think that compiler is actually solving it by applying operator precedence. No, it is converting that expression to postfix and then evaluating it. Okay, that's why we are here to study the conversions. So in that we don't use prefix. I will talk about that. First, the second application of stacks is converting a given infix expression to postfix. Okay, so let's see that algorithm, how we convert a given infix expression to a corresponding postfix expression. So these are some examples we have seen. Based on operator precedence, we can convert a given expression, but the important point is that brackets has more priority here, right? So this is the operator precedence. You have to always remember, right? This is very important. Even for understanding this concept, in our algorithm itself, we will be using this table, operator precedence table. We will be using it widely. So this you remember it. So we have so many operators. I'll not focus much on this. You already learned this in C programming. Let's go. Let's try to understand the algorithm for infix to postfix conversion. How do you convert a given infix expression? Actually, this infix to postfix conversion is a part of your compiler. Your compiler has this algorithm. That's why when you are giving this expression, it is converting automatically into a postfix expression and then it is evaluating it. Okay, so let's try to understand what is done, but small insights about that, why we have to study, why we have to convert a infix expression to postfix expression. Let us see that. right? Let's see. One, if you see, this is the expression, this is my infix expression, 2 plus 3 into 4. Among these two operators, plus and multiplication, which one is having more priority? Multiplication is having more priority. So I will convert this to 2 plus 3, 4 star. I converted this block 3 into 4 to postfix. It became something like this, 2 plus a single string here, that is 3, 4 star. Now I have to again convert this to postfix. So it is like a plus b. I have to write a b plus. So it becomes 2, 3, 4 star and then plus. It becomes 2, 3, 4 star and then plus. Right? So this is the postfix expression for the given expression. If you see the important observation, notice that between infix and postfix, the order of numbers is not changed. See, first we have 2, then 3, then 4. Same order exists in the postfix also. The order of numbers is not changed in the postfix expression. Okay, then in this case it is 2, 3, 4 in both the cases, but the order of multiplication and plus is affected. They have changed. Okay, so one more advantage, only one stack is enough to convert a infix expression to postfix expression, right? So the stack that we use in algorithm will be used to change the order of operators. Only why number order is not changing, so we should not be worried about it. Only the operator order is changing, that we have to focus on. Okay, let's see how we are trying to do the logic. Okay, see, postfix expressions do not contain parentheses. It does not have any brackets. If there were some brackets here like this, it does not have any brackets. Okay, we shall output the parenthesis in the postfix output as it is. If there is something, you can you don't print it. Even if there is some expression like this, in the output you ignore these symbols. Ignore these symbols. Okay, let's understand the algorithm. Let's see the logic, how we convert a infix expression to postfix expression. Okay, so this is one implementation or one application of stacks. We use stack data structure to do that. Okay, before I come to the algorithm, we will go and see an example and then come back. Okay, let's quickly see. Create a stack for each character t. If t is an operand, just output it. If it's a variable, output it as it is. If t is a right parenthesis, pop and output until a left parenthesis is found. Else if none of them, then you have to pop and output tokens until one of the lower priority character is encountered. Okay, we will understand this much better. We will come back to this algorithm and revisit again before we see an example. Okay, so I have an example here. So what is the character I am taking? And then I have operation stack. Operation, I am using the help of a stack and the postfix expression. Okay, let's see how does the algorithm works. So this is my string, right? This is an expression. It means it's a string. It is a string. Take the first character. What is the first character? A. Okay, whenever you encounter a operand, see here, operand means when you encounter a variable, what you have to do? You have to just push it directly into the expression. Push that directly, just output it. Just output that. Operation is output, your stack is still empty. Don't fill. Why? We are using stack only to fill the operators. Okay, so that's why I have character here a and output operation is output directly, add it to the postfix value. Then read the next character, that is star. Whenever you encounter a operator, what you have to do? You have to push that into the stack. Right? Then again, I got some next character is B. What you have to do whenever there is a B? Simply output it. So the stack still remains star. Here it becomes AB. Here it becomes AB. Next, the next character in the string is minus. Okay, this is the logic. Whenever you encounter an operator, you compare the precedence of this operator with this operator. Compare the precedence of the minus operator and the operator on this stack. Which one is having more priority? Star is having more priority compared to minus. Star is having more priority compared to minus. In that case, what I have to do? You have to push. First, you have to pop the operator, add this star here, okay, and put minus into the stack. Okay, add this star outside into this postfix expression and put this minus onto the stack. Now, next one was round bracket. Whenever is this round bracket, you need not do anything. Okay, you can push that symbol. You can again push that symbol. So minus, right? We can push that into the this. So this becomes minus. Yeah, it becomes minus this. So this remains AB star. Next, you got C. C is an character. It's a variable. I have to just output it. So this remains same, and this becomes AB star and C. Then I got plus. When there is plus, what you have to do? Maybe there is some space constraint. I hope you understood what I am doing here, right? Whenever there is plus constraint, you have to check it. So is the priority high or low for both of them? No. So you just push into the stack. It becomes minus this, and this remains same. Now you encounter a D. You encounter character. You have to just output it. This remains same. It becomes AB star CD. Okay. Next, I will just erase a few of these things. I'll continue here itself. Right. So next, next came the close bracket. When the next character was close bracket, what you have to do whenever there is a close bracket? Pop out all the elements till you encounter a open bracket. Okay, so you have to pop it out until you encounter a open bracket. So what is there in the stack? Plus is there, and then round bracket is there. So your stack remains only minus, and whatever was there inside the stack till you encountered open bracket should be popped out and added to the result. So it becomes AB star CD plus. Right? Next operator is plus. When there is plus, what you have to do? Compare with this current stack. Is this current stack operator, is it having more priority compared to plus? No, both are having same priority. Then just to push it, add it. It becomes minus plus, and the expression remains same. AB star CD plus. Next, I got E. Whenever you get E, simply output it. So this stack remains minus plus, and the expression becomes AB star CD plus. Okay, and E will come here. Okay, let me erase a few of them. Right. Now you have reached the end of the string. Once you reach the end of the string, pop out all the elements of the stack. And add it to the postfix expression. So here it becomes AB star CD plus E plus and minus. Okay, it becomes right. Yeah. Oh no, something we missed it. Minus. Plus came. Yeah, here when plus came, we will not put it here. We will remove the minus. We'll put it plus here, and minus will come here. Okay, when plus came, E and then plus and the final one, right? So let's see this example here, how we are doing it. Same thing. What is the algorithm here? A character, add it to the output screen. When there is a symbol, push it onto the stack, and this remains same. Then when you have a character, again add it to the output string. When there is minus, compare this minus with the existing stack. Among these two, which one is having more priority? Star is having more priority. So pop out this star and push this minus into the stack. Okay, pop out the star and push this minus into the stack. Then I got a round bracket, add it to the stack directly. Then I got a character, add it to the output string. Then you got a plus symbol, add it to the stack. Then you got a D, directly push it to the output string. Then you got a close bracket. Whenever you get a close bracket, pop out all the elements in this top of the stack till you encounter an open bracket. So stack is something like this. Till open bracket means only plus is there. So that you pop it out and add it to the expression. So the stack became only minus. Then again the operator plus came. So you have to compare this minus with this plus. Compare this minus with this plus. If the one which is having highest priority, then move that. If both are having same priority, then move this minus here, add this plus to the stack. So that's why the stack became plus and minus came here. Then the next character was E. So we have added E here. If once you reach the end of the string, pop out everything what is there in the stack. You can push it like this. So it becomes, this is the corresponding postfix expression. I will just go through the algorithm. We will see more number of examples, but let's recall the algorithm. Create a stack, scan for each character. From that string, you take each character. If T is an operand, okay, if T is an operand, means if it's a variable, just add it to the output. If T is a right parenthesis, pop and output tokens until a left parenthesis is popped out. Okay, pop until a right parenthesis, left parenthesis is encountered. Okay, else if none of the case, what you have to do? Pop and output tokens till one of the lower priority is encountered or a left parenthesis is encountered or the stack is empty. Okay, push it. Once this logic is over, pop and output tokens until the stack is empty. Okay, let's take some simple complex examples and try to solve this for infix to postfix conversion. Okay, do we have space here? Yeah, there is some other string here. Let's try to solve this. There is one more string. Let's try to solve this. Right. So I will have my character. I will have the operation. You have to write the table like this. Okay, and I will have my the stack and the postfix expression. Okay, read the first one. It is A. So you have to just output it. Just output it. Stack remains empty. A comes here. Then this is first line. Second, plus comes. Just push that into the. Let me write it little near by near. When plus comes, just push it. Okay, this is done. Next, when plus came, push that into stack. Stack became plus, and this remains A. Next one came B. Whenever B comes, just output it. So the stack remains plus, and this becomes AB. Whenever multiplication came, now you see when multiplication came, you compare with the stack and the star. Which is having more priority? Star is having more priority. So you have to just output this. So plus remains here and it becomes AB star. Next came my operator C. Simply you have to just output it. This becomes plus, this becomes AB star and C. Next, right? Next one came minus. Next one came minus. So when minus came, what I have to do? I have to compare. I have to compare this minus with this existing stack element. I have plus here in this stack and there is minus. Both are having same priority. When both are having same priority, you pop out the stack element and insert this new element into the stack. Okay, so kind of a push and pop both. So this plus will be added to the expression and minus will come here. This becomes AB star and C plus. Now then came D operator. D means simply output it. So stack remains minus. This becomes AB star C plus D. AB star C plus D, right? Next, I got divide by operator. I got divide by operator. Which one is having more priority in divide by operator? Divide by operator or this minus? Divide by has it. So simply output that. So stack remains minus. This becomes A, B star, C plus D and slash. Then you have the final one E. So E means simply output it. So stack remains minus. This becomes A, B star, C plus D slash and E. We have reached the end of the string. When you reach the end of the string, pop out all the elements of the stack and add it to the expression. So this becomes A, B star, C plus D by E minus. So this is the corresponding postfix expression. This is the corresponding postfix expression for a given infix. Even if you do it manually and see, let's see whether if you do this manually and see, first we have to do this. So this becomes A plus BC star minus DE by, we get it like this. Then we have to do plus. So this becomes ABC star plus minus DE by. Then it becomes ABC star plus DE by minus, right? So this is how you can still do it, but we are writing it using an algorithm to convert a given infix expression to postfix. Okay, create a stack, then iterate over each character. If there is a character, output it as it is. If it's a right parenthesis, sorry, this one. If it's a right parenthesis, until a left parenthesis occurs, you keep popping out the elements. Otherwise, if there is some operator, you compare that operator with the existing stack operator. Whichever is having high priority, that you have to output it. Remaining all should be kept as it is. Once this logic is over, at the end, if the iteration of the string is over, at the end, whatever elements are there in the stack, you pop it out and add it to the expression, right? So this is the algorithm of converting infix to postfix, right? We will see the implementation of this in the next session.